Right. The first case we have discussed in detail. Even the second with the question also, we have discussed examples, two examples on the first case. Then the second case, it's formula and the proof we have discussed. The required formula is, second case is only used for linear sine and linear cos. But if the function is not linear, then we can reduce it into linear forms of sine and cos with the help of these formulas. We have solved the questions also. Case number third we have discussed, right? So what we do, we will discuss all the cases for shortcut, and then we will discuss the combined example. Okay. So let's start with the case number 4. And let me discuss the case third again. What the third case is, for the hyperbolic sine and cos functions, what we do, we either replace d square by a square, or we can represent hyperbolic sine and cos in terms of exponential, and ultimately we can use the first case only, exponential case, which says replace d by a. Okay. So some of the questions can be easy to solve with the help of direct replacement by d square by a square, and some of the question will be easy using the exponential forms of hyperbolic function. Now the next case, case number 4, it says when fx is a polynomial function. Okay, like x square x cube, or 1 plus x square 2 plus x cube, like this, etc. Right, having some degree of polynomial. I hope everyone knows about the degree of polynomial, right? So for the polynomial function, how do we get the particular integral? We have the formula pi equals to 1 upon phi of d f of x. So here f of x is a polynomial function of the form x raised to m. So what we are going to do here, we are going to expand this 1 upon phi of d with the help of expansion formulas, which are obtained by using Taylor's and Maclaurin series expansions. So we convert this 1 upon phi of d into one of the formula of 1 upon 1 plus p, or 1 upon 1 minus p. And then we expand these two expansions. We know the expansion of 1 upon 1 plus p is 1 minus p plus p square minus p cube plus p raised to 4 minus, and so on. And the expansion for 1 upon 1 minus p is 1 plus p square plus p cube plus, and so on. Isn't it? These two expansions you must have used 1 upon 1 plus x, or 1 upon 1 minus x using. Okay. So we convert this 1 upon phi of d into one of the form, and then we use their expansions, and then we operate that expansion over this function x raised to m. Like suppose if I have excuse me, if I have 1 upon, say, d square plus 1, and that is if I want to operate it on x cube, then first of all check whether this 1 upon phi of d is of this form, one of the form. So the point is yes, it is of the form 1. It can be written as 1 upon 1 plus d square. So if you compare this with this, p is d square, and that is operated on x cube. So we use the expansion of 1 upon 1 plus p to this. So what we get? 1 minus p, where p is d square, plus p square that is d square square minus p cube, that is d square cube, plus and so on. This is infinite expansion and that is operated over x cube. ठीक है. So 1 minus d square plus d raised to 4 minus d raised to 6 plus and so on x cube, isn't it? यहां तक क्लियर है सबको?
Yes, sir.
Now the point is how many terms we have to consider from this infinite expansion. So for that purpose, we all know that when I operate d onto x cube, it means what? Derivative of x cube. So what it is? It is 3x square. When I operate one more d onto x cube, that is d square of x cube is d of x cube, isn't it? That is d of derivative of x cube is 3x square. So what is its derivative again? That will be 6x, isn't it? Now when I operate one more d, that is d cube of x, how much it will be? It is just 6. When I operate one more d raised to 4 of x cube will be, how much it will be?
0.
0. And further all powers will be 0. You can see d raised to 5 of x cube is equal to 0, d raised to 6 of x cube is equal to 0, and so on. Okay. So what we do, we have observed here that the degree of polynomial is the order or the power of that d there in the expansion, है ना? For which we are getting the non-zero term, non-zero value, and for the remaining, that means for the higher power than degree, we are getting 0. So it means what? We neglect all those higher power. So what is the degree of polynomial here? 3. So we consider only the powers of d up to 3 only. We neglect all those further powers. Is it clear?
Yes, sir.
So 1 minus d square, because d raised to 4 of x cube is 0, we have seen just now, and d raised to 6 and further all derivatives. So these are only the terms from the expansion we consider x cube. And when I operate x cube inside, x cube into 1 minus d square of x cube. What is d square of x cube? It is 6x.
6x.
And this is your particular integral. We have eliminated d completely. Okay, so what the point is here, we need to convert that 1 upon 5 of d into one of the form, and then the expansions. That's it. So this is for the polynomial function. Next is, any question, any doubt for this case? Everyone please do reply in chat box. अगर किसी को कुछ डाउट हो तो पूछ लो प्लीज. Everyone reply in chat box. Only Neeraj have replied. Okay. So the next case, case number 5. It says when the right hand side function fx is a product of the two functions e raised to ax into v, where v is a function of x above. ऊपर जो हमने फंक्शन डिस्कस किए उनमें से कोई भी होगा ये फंक्शन, either v is polynomial function or the sine or cos function or hyperbolic sine or cos function. So the formula of particular integral for this method is 1 upon phi of d e to the power ax into v can be written as, see here, this is very important. For this we write this exponential function outside the operator. यहाँ operator कौन है? 1 upon phi of d. So we write this exponential function outside the operator first. That is the first step. And then immediately we replace this d by d plus a, and that is operated on v. हम्म अभी एक्सपोनेंशियल का काम हो गया. डोंट इन्वॉल्व दिस एक्सपोनेंशियल फंक्शन इनसाइड नाउ. ठीक है, इसका काम क्या था? डी को रिप्लेस करना डी प्लस ए से. क्लियर टू एवरीवन? देन वी प्रोसीड विथ द फॉर्म्स ऑफ v. अगर v आपका पॉलिनोमियल है देन वी यूज द लास्ट केस. इफ v is sin or cos then we use the second case. Clear to everyone?
Sir, is it similar to the chain rule?
uh, Not exactly the chain rule. This is because of the product rule actually. Product rule. Instead of chain rule we can say the product rule, because when we go on taking the derivative, just like we have seen for the sine and exponential, what we do, we start with the taking derivatives of this e raised to ax into v by product rule of differentiation. Okay, we go on taking the derivatives, and then at certain stage at nth derivative, hmm, nth derivative we will get, suppose the first derivative, what is the derivative of e raised to ax? It will be e raised to ax product sorry, e raised to ax into derivative of v product rule plus derivative of e raised to ax, that is a e raised to ax into v, right? So I can write this as a e to the power ax into d plus a operated on v. Similarly, if I take one more derivative, d square of e raised to ax into v, I will take the derivative of this. So what I'll get? I'll get of the form e raised to ax into the similar form of d plus a the whole square into v. Because this d plus a is constant, I'll write outside, and e raised to ax ka derivative the same. Clear? So and so on. When I proceed with the nth order derivative e raised to ax into v, how will it be? It will be like this: e raised to ax into d plus a the whole raised to n into v. Yes or no?
Yes, sir, got it.
So instead of only d raised to n, we can have the functions of d, that is phi of d operated on e raised to ax into v will be equals to uh, e to the power ax into function of this d plus a raised to n, or d plus a simply. And by interchanging the role of this phi of d, we will get our required formula by taking uh, phi of d plus a into v को अगर मैं कुछ अलग डिनोट करता हूँ इसको, if I denote it as a v1 suppose, then phi of d plus a into v as a v1, then यहाँ से मैं v का वैल्यू लिख सकता हूँ v is equal to 1 upon phi of d plus a that is operated on v1. Therefore, if I substitute the value of v1 into this, what I'll get? I'll get it to be phi of d into e to the power ax into this 1 upon phi of d plus a operated on v1, that is equal to v1. E raised to ax into v1 ना, ये वाला. Isn't it? So if I operate 1 upon phi of d, or if I divide both sides by phi of d, what we get? E raised to ax into 1 upon phi of d plus a operated on v1 will be equals to 1 upon phi of d e raised to ax into v1. तो यहाँ से मुझे फॉर्मूला मिल गया. इंस्टेड ऑफ v1, if I say v only, then I'll get the formula of particular integral. Clear to everyone? So
Yes,
this
sir.
is the logic behind the formula actually. So here, to use this case, first of all, exponential function is necessary. We cannot use for any function of x. Exponential function must here, and v can be any function from the above. That is the only necessary thing for the to use this case. The next case, case number 6, when the right hand side function fx is the product of x into v. Okay, where v is a function of x above. So for this case, the formula for particular integral is pi equal to 1 upon phi of d f of x, which is x into v, will be equals to, see, this is very important. How do we write the particular integral? That will be x minus 1 upon phi of d into derivative of phi of d, that is phi dash of d, the whole into 1 upon phi of d operated on v. This is the formula for the case number 6, and the logic is same, just like we have discussed in the case number 6. What we do, we go on taking the derivatives of this x into v, isn't it? We will get the formula just like the previous case. So this is the formula for case number 6.
Sir, if the v is a function of x, then isn't it similar to the x raised to m condition?
uh, it will be if v is a polynomial. If v is a polynomial in particular, then that will be similar to the case number 4. You're right. But if v is not polynomial, like sine ax or exponential, we can say, if v is e raised to ax, then that will be similar to the case number 5 also. Am I right?
So, if there is x sine ax, for example, then it
Ha, ha.
won't be. Okay, okay, got it.
Yes, x sine ax, isn't it? So that will be of the form x into v. But if it is x cube, then I can write x cube as a x into x square, where v is x square. Right?
Yes, sir. So this will be more generalized form.
Yes, yes, exactly. Okay, so this is the 6th case. Now here, uh, there is a remark to use this case. Remark. Is this properly visible? Is the screen properly visible, or is it too small?
It's visible, sir.
Uh, is it okay now? Because I think that was too much small. Anyways, the first remark is, to use this case, the power of x must be 1. ये जो x है, इसका power 1 होना चाहिए. This case is not. Uh, this case will not be useful for x square into v kind of function. X square, x cube, and so. The power of x must be 1. This is the first note. And the second is, to use this case, ये जो दिख रहा है आपको लास्ट में 1 upon phi of d into v, that should not be the case of failure. So 1 upon phi of d into v should not be the case of failure. ठीक है, क्लियर आपको? क्लियर. केस ऑफ फेल्यूर मीन्स व्हाट? phi of d must be 0. सॉरी, केस ऑफ फेल्यूर का मतलब क्या होता है? phi of d 0 होता है. तो दैट शुड नॉट बी द केस ऑफ फेल्यूर, मीन्स phi of d मस्ट बी नॉन जीरो. क्लियर टू एवरीवन? अगर ये नॉन जीरो है, केस ऑफ फेल्यूर नहीं है, then only we can use this case, otherwise we cannot. So if power of x is 1 and 1 upon phi of d v is a case of failure, अगर ये case of failure है, then we use the next case. That is a case number 6. What it says, for example, as a function. For example, 1 upon d square plus 1 x sine ax. You can see when I operate the formula, what the formula says, x minus phi dash. You can see the formula first. See the formula, x minus phi dash upon phi into 1 upon phi operated on v. So x minus phi dash. What is phi dash here? 2d upon phi, that is d square plus 1, and that is operated on 1 upon phi of d, that is d square plus 1 sine x. And if you look at this, when I replace what the case of sine says, what the sign says, second case, it says replace d square by minus a square. Yes or no? So when we replace d square by minus 1, that will be a case of failure. Yes or no?
Yes, sir.
So ऐसे नहीं होना चाहिए. This should not be a case of failure. And if it is like this, then to proceed with the shortcut, we need one more case. That is a case number 6. Sorry, case number 7. It says when the right hand side function is of the form x raised to m sine ax or x raised to m cos ax. That's it. ठीक है. तो what this case says, तो पहले तो इसको डिस्कस करने के लिए थोड़ा सा पीछे जाते हैं हम. पीछे मीन्स वी डिस्कस सम बेसिक्स ऑफ कॉम्प्लेक्स. वी ऑल नो दैट Euler's formula e to the power I theta can be written as cos theta plus I sin theta, isn't it? So what is cos theta in this? This is of the form a plus ib. So what is cos theta? Cos theta को मैं क्या बोल सकता हूँ? Cos theta is real part. Just a minute, huh? Excuse me. I'm sorry. So what is cos theta? Cos theta is the real part of this complex number, real part of cos theta plus I sin theta, isn't it? But this is nothing but what? E raised to I theta. So that is the real part of e to the power I theta. And similar manner, sin theta is what? Sin theta is imaginary part of cos theta plus I sin theta. So it is imaginary part of uh, e to the power I theta. यहाँ तक क्लियर है सबको? Everyone, please do reply. ये सबको मालूम है एक्चुअली, है ना? Because a is called the real part and b is called the imaginary part, na? So if I compare this with cos theta plus I sin theta, a is cos theta and b is sin theta, but b is imaginary part, so sin theta is imaginary part. Yes or no? Everyone, please do reply. Everyone. Hello, hello. Mic check. Hmm? Okay. Yes. So what we do, We write this theta as a ax. So I can write this as a e to the power ax क्या होगा cos ax plus I sin ax. तो अगर मैंने x रेस टू m से मल्टीप्लाई कर दिया तो e रेस टू x रेस टू m e रेस टू ax क्या होगा x रेस टू m cos ax प्लस x रेस टू m सॉरी I टाइम्स sin ax, इजंट इट? तो यहां से मैं लिख सकता हूं कि x raised to m cos ax is the real part of x raised to m e to the power ax. एंड एक्चुअली कुछ मैंने गलत किया क्या? आई ना, यहाँ आई होना चाहिए, e raised to I theta. Am I right? हाँ, e to the power I ax and x raised to m sin ax is imaginary part of x raised to m e to the power I ax. ठीक है, तो अभी मैं फॉर्मूला लिखता हूं यहां से पर्टिकुलर इंटीग्रल का, देयरफॉर 1/phi of d ऑपरेटेड ऑन x रेज टू m sin ax. सपोज अगर मैं साइन लेता हूं तो दैट विल बी इक्वल्स टू 1/phi of d imaginary part of, instead of this x raised to m sin ax I can write imaginary part of x raised to m e to the power I ax. तो इसका इमेजिनरी पार्ट मतलब, आर यू एबल टू सी दिस? when I solve this, when I write the expression for e raised to I ax and when I multiply by x raised to m, that will be of the form a plus ib, and उसमें से सिर्फ imaginary part I want. Hello, is the point clear?
Yes, sir.
So I'm talking about only b. Imaginary part means only b for this particular form, only b. So that is like 1/phi of d operated on b only, where b is the imaginary part of the expression. So so by taking imaginary part of this expression and then then operating 1/phi of d onto b is same as by operating 1/phi of d onto this expression e raised to x raised to m e raised to I ax and then taking imaginary part of that. That is one and the same. मैंने क्या किया पता है? इमेजिनरी पार्ट जो है उसको बाहर लिया, विल गेट द सेम थिंग. मतलब इसका मीनिंग क्या है कि पहले इमेजिनरी पार्ट निकालो एंड उसके ऊपर 1/5 डी को ऑपरेट करो, इज सेम एज पहले 1/5 डी ऑपरेट करो एंड देन उसका इमेजिनरी पार्ट कंसीडर करो. इज इट क्लियर टू एवरीवन व्हाट आई एम ट्राइंग टू शो हियर? हेलो.
Yes, sir.
हाँ, so
So,
therefore,
can you
हाँ,
please
yes,
explain it once again?
हाँ, see here, first of all, is this two formula clear? X raised to m cos ax is the real part of this and x raised to m sin ax is the imaginary part of this. ठीक है? हेलो,
Yes, sir.
या स्टार्टिंग से एक्सप्लेन करूं? कहां से एक्सप्लेन करना है मुझे?
Sir, from the formula only you can explain, sir.
ओके ओके फाइन. तो वी आर डिस्कसिंग द केस फॉर x रेज टू m sin ax. तो अगर मेरा साइन और cos है ना, तो मैंने साइन पकड़ लिया, साइन अगर है तो x रेज टू m sin ax को मैं कैसे लिख सकता हूँ? x इमेजिनरी पार्ट ऑफ दिस, सो दैट इज व्हाट आई हैव रिटन. सो व्हाट आई एम सेइंग हियर, इसका इमेजिनरी पार्ट विल बी जस्ट लाइक b, है ना? इसका जो ये जो एक्सप्रेशन है इसका इमेजिनरी पार्ट इज सपोज b फ्रॉम a plus ib, है ना? एंड देन वी आर ऑपरेटिंग 1/phi of d onto that b. ठीक है, is same as we operate 1/phi of d onto this and then we take its imaginary part, we will get the same value because 1/phi of d क्या है? That is just an operator. वो कुछ चेंज नहीं करता फंक्शन में, वो ऑपरेट करता है फंक्शन को. ठीक है, तो आई हैव टेकन जस्ट इमेजिनरी पार्ट आउटसाइड द ऑपरेटर. इस इमेजिनरी पार्ट को मैंने ऑपरेटर के बाहर लिखा है. क्लियर? अगर फिर भी नहीं समझ में आ रहा है तो जस्ट लेट मी शो यू. फॉर एग्जाम्पल, 1 upon, say, take simple d plus 1, d plus 1 suppose, हाँ, और डी स्क्वायर प्लस 1 लेते हैं, एंड एक्स स्क्वायर साइन एक्स ऐसे लेते हैं फंक्शन. सो दिस, इसको इसको कैसे लिख सकते हैं हम? दैट इज as it is x of the form x raised to m sin ax, that will be imaginary part of 1 upon phi of d, that is d square plus 1 x raised to m e to the power I ax, that is ix only. क्लियर? तो पहले तो मैं इसको सॉल्व करूंगा, सॉल्व करते जाऊंगा. फाइनली व्हेन d is getting eliminated throughout, then I'll get the form of this type 1 upon sorry a plus ib. yes or no? इसको जब मैं पूरा सॉल्व करूंगा, I'll get the expression of this form. Hello?
Yes, sir.
And then from that I need only its imaginary part, because imaginary part is outside of that. The imaginary part of that expression is, what is the imaginary part? That is simply, it is, what is the imaginary part here? This is real part and this is imaginary part, na? So imaginary part is
B.
b, and that is our required particular integral. And that is same as, मतलब मैं क्या बोल रहा हूँ कि अगर इमेजिनरी पार्ट यहाँ भी लेते हैं, इसको सॉल्व करके इमेजिनरी पार्ट, एंड देन ऑन टू दैट व्हेन वी ऑपरेट 1/5d, दैट इज सेम एज दिस. ठीक है? तो अब से हम यही लिखेंगे कि 1/d² और 1/5d x raised to m sin ax is imaginary part of this, and then we go on solving this, and then we try to separate its real and imaginary part. This is real part and this is imaginary part. Real and imaginary part को separate लिखेंगे, and then out of that we need only the imaginary part for sin x, and if it is cos, then we need only the real part. Is this point clear now?
Yes, sir.
So let me write the formula again. 1/phi of d x raised to m sin ax is imaginary part of 1/phi of d x raised to m e to the power I ax. And for cos, like this is the first formula, and the second is 1/phi of d x raised to m cos ax is same as, or it equals to, real part of 1/phi of d x raised to m e to the power I ax. Clear? Is this clear?
Yes, sir.
Let us take a simple question onto this. So this point is will be clear here only. For example, solve d raised to 4 plus 2d square plus 1 times y equal to x square cos x. So we find its complementary function first. To find the complementary function, we consider the auxiliary equation d raised to 4 plus 2d square plus 1. तो क्या होगी इसके रूट्स? This is actually the expansion of d square plus 1 the whole square. Yes or no? So it gives the root d equal to plus minus I plus minus I. Isn't it? So with this two complex repeated root, how do I write the complementary function? Cf is equal to e to the power alpha. Alpha is 0. X into c1x plus c2. If you remember, we have discussed the case for complex repeated root. c1x plus c2 cos beta. What is beta here? 1. Cos beta x plus c3x plus c4 sin beta x. Beta is 1. ठीक है. Now particular integral pi equal to pi, we start with the formula 1 upon phi of d f of x. We substitute phi of d and f of x. What is phi of d here? It is say d square plus 1 the whole square, and f of x is what is f of x here? x square sin x square cos x. ठीक है, यहाँ तक क्लियर है सबको?
Yes, sir.
So what the last formula says, for x raised to m cos ax, we can write this as a real part of 1 upon d square plus 1 the whole square. किसका real part? x square e to the power I ax. A is 1, so I x only. तो अभी इसको सॉल्व करेंगे ब्रैकेट में जो है उसको. सो रियल पार्ट ऑफ, हाँ, हाउ डू वी प्रोसीड फर्दर विद दिस केस? दिस इज ऑफ द फॉर्म, यस, दिस इज ऑफ द फॉर्म e to the power ax na. This is of the form e to the power ax into v, yes or no, where v is x square.
Yes, sir.
So this is of the form e raised to x into v. So what this case says, एक बार देख लो, case number 5 I guess. हाँ, this one. So what this case says, write the exponential function outside the operator and मैंने formula पहले लिखा था, हाँ, write the exponential function outside the operator and then replace d by d plus a operated on v, isn't it? So we do the same thing here. We write the exponential function outside the operator and immediately we replace this d by d plus a. What is a here? Hello, what is a?
1.
A is not 1.
It's I.
I. See
I.
here.
I. E raised to x.
So replace d by d plus I square plus 1 the whole square, and that is operated on x square. That is real part of e to the power ix. And now we solve, we simplify this denominator first, that is 1 upon इसको expand करो तो that will be d square plus 2id and plus I square, that is minus 1, and a plus 1, isn't it? The whole square, that is operated on x square. So that is equal to real part of e to the power ix 1 upon d square plus 2id operated on x square. यहाँ तक clear है सबको? Everyone please
Sir, whole
reply.
square.
Yes, sir.
Yeah, it's whole square. Very good. So what we do, we can expand this. That is अभी अभी हमें सिर्फ इसको सॉल्व करना है, इसको, इतने को, एंड दैट इज फॉर द पॉलिनोमियल फंक्शन, वी ऑल नो, है ना? तो पॉलिनोमियल फंक्शन के लिए क्या करते हैं हम? इसको एक्सपांड करते हैं, e raised to I x will be as it is, है ना? तो पहले मैं डिनोमिनेटर को एक्सपांड करता हूँ, दैट इज d स्क्वायर स्क्वायर इज d raised to 4 प्लस 2 to the 4 I d क्यूब ना, चॉइस ए बी, है ना, प्लस b square. So 2id square, that will be minus na, because I square will be
Minus 4D square.
minus 4d square, that is operated on x square. ठीक है, तो रियल पार्ट ऑफ e to the power ix. हाँ, अभी क्या करते हैं हम? We want 1 in the denominator. So how do we get 1? We take 4d square common. In fact, minus 4d square if I take common, what I'll get inside? It will be 1 here. 1 minus d raised to 4 plus 4i d cube the whole upon 4d square. Yes or no? Am I right?
Yes.
X square. So So that can be written as real part of e to the power ix into पहले तो मैं इसको लिखता हूँ -1/4d² एंड इसको 1/1 माइनस व्हेन आई टेक, तो ये क्या होगा d² प्लस 4id अपॉन 4x². ठीक है, so this is our p, this bracket is our p. So let us expand it now. I hope everyone is able to recall the case for x raised to m, fourth case. So what the fourth case says, we need to expand this 1/1 minus p. तो
1
पहले
plus p square.
हाँ हाँ यस, पहले तो इसको सॉल्व करते हैं फिर इसमें सब्स्टिट्यूट करते हैं हम, क्योंकि वो बहुत मतलब कॉम्प्लिकेटेड दिख रहा है अभी, तो लेट अस सॉल्व दिस फर्स्ट. सो कंसिडर, नहीं तो इसी में करते हैं चलो, अदरवाइज विल गेट कंफ्यूज्ड. सो दैट इज रियल पार्ट ऑफ e to the power ix into -1/4d². हाँ, अभी एक्सपांशन देखो. सो 1 प्लस p, व्हाट इज p, d² प्लस 4id अपॉन 4. तो पहले तो सबको क्लियर है कि d के कौन से पावर तक एक्सपांड करना है, मुझे कौन से पावर तक टर्म्स लेना है?
First power.
नो, सेकेंड. व्हाट इज द डिग्री ऑफ पॉलिनोमियल? 2 ना. तो d² of x² will be non-zero, d³ of x² will be 0. See here, d of x² will be 2x, d² of x² will be 2 na, and d³ of x² will be 0, and further all derivatives will be 0. So we consider the powers of d up to 2 only. Clear?
Yes, sir.
So 1 plus p² that is d² plus 4id upon 4 the whole square plus and so on, and that is operated on x². तो अभी इसको रियल पार्ट ऑफ e raised to ix -1/4d². क्या होगा इसका? इसमें कौन से पावर d² तक आएंगे? 1 फर्स्ट टर्म विल हैव टू कंसिडर, राइट? तो दैट इज 1/4d². ये सेकंड भी आएगा ना, प्लस 4/4 विल इज गेटिंग कैंसल्ड, i d है ना, प्लस यहाँ से d² will be d raised to 4, that is neglected. Then twice ab में d³ आएगा, that is neglected. Only the last term will be there, right? So 4id the whole square is 16i², which is -1 minus 16d² upon 16. Yes or no? ये सबको क्लियर है? ये मैंने कहां से लिया?
Yes.
When I expand this, इसको जब मैं एक्सपांड करूंगा तो इसमें d² का स्क्वायर विल बी d raised to 4, which is neglected. Neglected क्यों? क्योंकि d raised to 4 on of x² will be 0. Then twice ab में d³ आएगा, वो भी neglected. सिर्फ लास्ट b² का टर्म जो है ना वो आएगा. That is what I have written here. And then I think cubic में कोई भी नहीं आएगा, है ना? So I'll have to stop here, and that is operated on x². So that is a real part of e raised to ix into -1/4d². Now I'll take x² inside, so 1 into x² plus 1/4d² of x² plus I d of x² minus 16 cancel, minus d² of x². So that is real part of e raised to ix -1/4d². x², ये कितना होगा? d² of x² is 2 ना, 2/4 is 1/2. हाँ, plus I d of x² is 2x, and here minus d² of x² is -2. ठीक है. So let us operate this 1/d onto this. तो 1/d का मीनिंग क्या है, कोई बताएगा? 1/d means
Integral.
integration. D is the derivative, so 1/d is integration. So we integrate this, and actually it is 1/d², so we integrate 2 times. That is real part of e raised to ix. let us write this as a minus c raised to I x upon 4 1 upon d of 1 upon d, that is integration of x square minus 1 by 2 1 by 2 minus 1 by 2 minus 2 कितना होगा ये -3/2 ना प्लस 2ix dx तो क्या होगा ये that is equal to real part of minus e raised to I x upon 4 1 upon d into integration of this is x cube by 3 plus 2 I x square by 2 तो I x square minus 3/2x. Please let me know if anything wrong in the calculation. That is real part of minus e raised to I x upon 4 1 upon d means again integration of this. तो क्या होगा ये that will be equals to oh I think it's time na we have crossed the time e raised to minus e raised to I x upon 4 and integration that will be x raised to 4 by 4 so x raised to 4 by
12.
plus I x cube by 3 minus 3/2 x square by 2 so 3/4. ठीक है तो अभी हम क्या करेंगे इसको e raised to I थीटा को इसके रियल एंड इमेजिनरी पार्ट्स में लिखेंगे सो हाउ डू आई राइट क्योंकि अभी अभी तो d कंप्लीटली एलिमिनेट हो गया लेकिन हमें चाहिए दैट एक्सप्रेशन ऑफ द फॉर्म a प्लस आई बी इसको इस फॉर्म में लिखना है हमें तो उसके लिए हम उसके रियल एंड इमेजिनरी पार्ट सेपरेट कर रहे हैं अभी देखो कैसे रियल पार्ट ऑफ -1/4 ई रेस टू आई एक्स को कैसे लिखते हैं हम cos x प्लस आई साइन एक्स राइट इनटू इसका रियल पार्ट कौन है x रेस टू 4/12 पहले तो इसको ऐसे ही लिखते हैं प्लस आई एक्स क्यूब बाय 3 minus 3/4 x square and now what we do we multiply these two brackets इन दोनों को मल्टीप्लाई करेंगे तो जो जो देखते हैं क्या होगा मल्टीप्लीकेशन रियल पार्ट ऑफ ये -1/4 को भी मैं आउटसाइड लिख सकता हूँ हाँ बिकॉज दैट इज कांस्टेंट इट डजंट मैटर -1/4 रियल पार्ट ऑफ cos x into x square by 12 plus I x cube by
So x
3
raised to
cos
4.
x huh?
X raised to 4 by
x raised
12.
to 4 x raised to 4 then this into this I have done then this into the last that is -3/4 x square cos x then now I times sin so plus I x raised to 4 by 12 sin x I into I square which is minus x cube by 3 sin x माइनस आई एक्स स्क्वायर साइन एक्स ठीक है तो अभी पूरा मल्टीप्लीकेशन हो गया अभी सिर्फ उसके रियल एंड इमेजिनरी पार्ट सेपरेट लिखते हैं सो दैट इज इक्वल टू -1/4 रियल पार्ट ऑफ इसका रियल पार्ट में पहले लिखता हूं क्या रियल पार्ट मतलब जो जिसमें आई नहीं है वो सो x रेज टू 4/12 cos x then -3/4 x square cos x then माइनस एक्स क्यूब बाय 3 साइन एक्स ठीक है प्लस आई टाइम्स क्या होगा एक्स क्यूब बाय 3 कॉस एक्स प्लस एक्स रेज टू 4/12 साइन एक्स एंड माइनस एक्स स्क्वायर साइन एक्स कैलकुलेशन सही है सो कैन यू
तर
सी दिस
3/4 मिसिंग आहे का
वेयर इट इज
लास्ट सेकंड लास्ट स्टेप मध्ये आय एक्स स्क्वेअर साइन एक्स
यस 3/4 इज समवेयर ना 3/4 हाँ यहाँ लिखा तो है मैंने ये देखो इट्स देयर ना
तर वरच्या स्टेप मध्ये
While multiplying it by sin x, you have missed 3 by 4.
uh, oh, I
लास्ट
into
टर्म.
I into ओके, या इसको इससे मल्टीप्लाई कर दिया, देन इसको इससे किया, एंड इसको इससे, ये तो है। अच्छा, 3/4 आई हैव नॉट रिटन, ओके ओके, दैट इज माइनस आई इंटू, हाँ यस, 3/4 इट मस्ट बी ना, राइट नो,
येस.
3/4, आई एम सॉरी। सो कहाँ था वो, आई में था, सो दैट मीन्स हियर ना, 3/4, इज इट ओके नाउ? So can you see this is of the form minus 1/4, a real part of the form a plus ib. Everyone, can you see this? This is a the whole bracket and this is plus I times the whole bracket as a b. तो इसमें से मुझे क्या चाहिए, सिर्फ रियल पार्ट चाहिए. सो हु इज द रियल पार्ट? a. तो -1/4 into what is real part? That is x raised to 4/12 cos x minus 3/4 x square cos x minus x cube by 3 sin x, and that is my final particular integral. Clear to everyone?
Yes, sir.
So actually I know this method is lengthier one and a bit difficult. No, it's not difficult actually, just be we have to be with the calculations. Hmm? Many more calculations are there, but don't need to worry about the calculations if you know what to do exactly, है ना? Then you can reach up to the last answer. Everyone, please do reply in chat box. Uh, everyone. Hmm? So